Welcome back to the whiteboard on the brick wall. So this will be the first of a series of videos about algebra, basic algebra. A little bit about the word. It comes from Arabic. No one's quite sure what it means, but the best guess so far is it means something like rearranging or putting together the pieces, which is an accurate description because algebra is all about moving around elements in an equation. And before we can do algebra, we have to learn about something called order of operations. By operations, we mean addition, subtraction, multiplication, division, exponents, and so on. There's a nice little acronym to remember the order of operations. It's PEMDAS. So this stands for parentheses, exponents, multiplication, division, addition, subtraction. So by symbols, I could do it like this. Parentheses, x power n. You have multiplication, division, or rather, sometimes multiplication we just use a dot up high, sort of like a high decimal point. Division we can use our division sign or a fraction bar, or plus sign. And our minus sign. So let's go do a couple of examples to show how PEMDAS works. Okay, so first letter of PEMDAS is parentheses, so we start with our parentheses. So 3 times 2 would be 6, so we'd have 6 power 2 minus, here we'd have 5 plus 3 squared, so 3 squared is 9. That's our exponents part. Continuing with the exponents, 6 squared is 36. Actually, I should do the parentheses. Well, they're both in parentheses, so this one would be 36. This one would be 14. 36 minus 14 is 22. So you work, just follow the order of operations, PEMDAS, and you get the right answer. No fuss, no muss. If I have so in parentheses again, we'd have 2 squared and 1, that would be 5. 4 plus, well, I don't want to skip too many steps. Over here, 9 minus 3 is 6. So we have 6 over 3. Back over here, this is we have 5 cubed. And that gives us 5 cubes 125. 6 divided 3 is 2. So our answer would be 127. So that's the gist of order of operations. The second, and I'd say the most fundamental concept in algebra is the the idea of the unknown. So we use the letter x to represent the unknown. And we'll see how this concept comes into play more when we talk a little bit about word problems. So the goal in algebra is always to get x by itself on the left side of the equal sign. So if I have an equation like this is our equation. Our goal is to get x by itself over here on the left. So the first thing I want to do is I want to get rid of this 2 that's dividing everything, or dividing everything on the right side. And so here we come again to another cardinal rule of algebra. Whatever you do to one side, you do to the other side. So what I do, I multiply both sides of the equation by 2. Like so. Okay, 2 times 5 is 10. 2 times 2x is 4x. 2 times 1/2 is 1, so we're just left with 6 minus 4x. Okay, I can subtract 10 from both sides, or actually I should add 4x to both sides. So I say plus 4x here, plus 4x here. That gives me 10 plus 8x equals 6. 8x equals 6 minus 10. So 8x equals negative 4. Divide both sides by 8. So I get x equals negative 4 over 8, which is the same as negative 1/2 when I reduce fractions. And as the algebraic equations get more complicated, it gets harder to get x by itself on the left. But that's always the goal, and there are various tricks you learn throughout algebra to learn how to do that. And suppose the next logical topic is the various algebraic properties. I think I should switch to another color here. So you have the associative property. And this one says that it doesn't matter how we group things by parentheses. So for example, if A, B, and C are all numbers, A plus B plus C is the same as A plus B plus C. So in other words, it doesn't matter how we group it. Second most important one is, or they're all important, but we have the commutative property. Perhaps I should state that one up top. And this one says that the order for multiplication and addition is not important. So for example, a plus b is the same as b plus a. And likewise, as we learned in arithmetic, I'm going to stop using x. When you get to algebra, you stop using x to indicate multiplication. So you can either use a dot, or you can just write the two numbers next to each other like this, or in parentheses. I'll use parentheses. A times b is the same as b times a. The last, most important, and the last algebraic property is the distributive property. And this applies to multiplication of something in parentheses. And this one would say that a times b plus c is the same as a times b plus a times c. And likewise, when you have something, if I had, say, so in other words, this relates to the process of factoring. In other words, the common factor in both AB and AC is A. So I can pull that one out like this and have something in parentheses. And this is particularly useful when you're trying to isolate x. If x is stuck onto two terms, you can pull it out like this. So let's see if I can come up with some example problems to illustrate these properties. It's a bit hard off the top of my head. Let's just continue with simplifying equations. I have, say, 2x minus 1. Let's see. Do a slightly simpler one. Okay. Whenever you have an equation, often you can see the clues of how to get x by itself by looking at what you have. So here we have the term with x is already on the left side, so we're not going to need to move x around. But we are going to need to figure out how to get it by itself. So what do we see? Well, first we see that the x term is being divided by 5, having 1 subtracted from it, and also being multiplied by 2. So we need, in order to get x by itself, we have to do the opposite of what's being done to it. So we would have to multiply by 5, add a 1, and then divide by 2. So we'd be doing the opposite of what we see. So if I start by multiplying both sides by 5, okay, if I multiply this side by 5, it cancels out the 5 on the bottom. 3 times 5 is 15. If I add 1 to both sides, I get 2x over here, because the plus 1 cancels out the minus 1. 15 plus 1 is 16. Now I divide both sides by 2, and I get x equals 8. And when you solve an algebraic equation, you generally don't need to write out every single step. You just need to write out the intermediate results of what you did is usually sufficient. If I throw in some more parentheses, so I have 4 times, I don't know, okay, now I have x's on both sides, but I still need to get everything out over on the left. So the first thing we can do is we can use the distributive property to get rid of these parentheses. So 4 times 5 is 20. 4 times negative x is negative 4x. Over here, well, I suppose we'll let that be our first step. next thing we need to do is we can multiply everything by 5 to get rid of this 5 on the bottom. So if I do that, 5 times 20 would be 100. 5 times negative 4x, negative 20x. Then I'd have 3x plus 7 over here. Okay. I can subtract 3x from this side to move it over here. So I would have 100 minus 23x equals 7. I subtract 100 from both sides, and I would have negative 23x equals negative 93. And then lastly, I divide both sides by negative 23, and I would get x equals 93 over 23. So x can be it can be a fraction, a whole number, a negative number, whatever it comes out to be. It doesn't have to be a whole number. Generally speaking, it's often that in these kinds of simpler algebra problems, x will turn out to be a whole number. So if it'll be something like 2 or negative 3 or whatever, and that can give you a hint on how to solve a problem. So if you're on a multiple choice test and you're stuck and you're not quite sure what the answer is, if the answer you get is close to a whole number, it's probably the correct choice. That's more like test taking advice rather than mathematical, but something I thought I'd throw out there. And I suppose that's all I wanted to do for this video, and we'll be moving on to more complicated algebra problems in the next couple videos.